Hello, chemistry family. We are going to be looking over lab 12 and figuring out molar mass. And to do that, I just wanted to guide you a little bit on some of the information that is about to lie ahead for you. So first of all, we've already done the lab. So you should have already written down how many grams it was of just your mass of your crucible plus the cover. You also should have taken the mass before the reaction with that black powder called silver oxide, with the cover and the crucible as well. Remember, the silver oxide, you were supposed to mass out about 1.75 grams of the substance, and of course, take into account the mass of the crucible and cover. Then after you cooked it for 15 minutes, you should have ended up with a product of silver, and you should have taken that mass as well. So since you had oxygen and cooked it off, and now you just have silver, technically the second mass, this one, should be less than the first one because you should have cooked some off already. So make sure that your data is correct. Check with your lab partners if something's off, but take a look at that to double check. Also, we did not do reheating. We never have time in class to do that. So you don't need a reheating data point if that is on your lab. All right, so we have that all set. When it comes to our first two calculations, they're very straightforward. If we want to find the mass of the pure silver, since we know we have pure silver at the end, we just need to take data C minus data A. So that just simply means whatever we got for mass data C, subtracted from A, and whatever you get left is just going to be the silver. So go ahead and do that for this one. For number two, and don't forget, you can pause this video while you do it and then restart it again. For number two, you're going to be finding the mass of oxygen. To find the mass of oxygen, you're going to take your observation data B and subtract C from it. So B minus C. Again, take a look at what that is. Your B minus C will give you the mass for oxygen, and you can put that in there. Now that you have all of your data taken, we're going to scroll up a little bit here and start working on converting our grams of silver to moles. So to do that, we're going to take our mass of silver, which is our calculation number one right here. We're going to take that mass of silver and you are going to convert it into moles. So basically, grams of silver, which is Ag, convert into moles. Now you know how to do that. Use your mole map in a one-step mole problem to get that. Look on your mole map. How would you convert the grams of silver that you got in the lab and convert that into moles? You're going to put that answer right there. Go ahead and pause this video, work out that problem, and then we'll move forward. For the next question, number 4, you need to convert your grams of oxygen that you calculated into moles. So we're going to take your grams of oxygen, O, and convert that into moles. To do that, let's take our calculation number 2. We already figured out how much oxygen we had in grams, and then let's use our mole map to convert those grams that you got from your data table and convert that into moles using your mole map. Once you do that, you should be fine and get that data point right there. Go ahead and pause, work on that problem, and then restart, and we can jump to 5. Now we're at number 5. It wants you to calculate the molar mass of silver according to our data. So the molar mass of silver is going to be taking the mass of silver that we have from the lab, which is from our calculations number 1. So we're going to take that data point, and we're going to divide it by the moles of silver that we calculated already in question number 3. So you're going to take the grams of silver divided by the moles of silver. So go ahead and work that problem out, do that equation, and then give your answer right there, pause it, and then we can move on to our conclusions and questions. Now before I move forward, let's think about our reaction that we had. We had this silver oxide and we heated it up really well, and it turned into pure silver and also oxygen. Now remember, oxygen, when it's all alone, because of Brinkelhoff, it's a diatomic molecule. It looks like this. But now that we have this, we have to balance that out and would end up with, for every 2 formula units of silver oxide, you end up getting 4 atoms of silver along with 1 molecule of oxygen gas. That's actually the reaction type, and we know that is a decomposition. Starts as one and breaks down into pieces. Just wanted to make sure we went through that of what type of reaction this was. But now we're ready to move on to question number 1. If you look at the molar mass that you found in question number 5, so again, just to refer to where we are talking, you just calculated that. Compare it to the one on the periodic table, and are you close or far away? So take a look at silver on your periodic table and look for the number underneath it or on top of it on the periodic table. It's molar mass. Now compare that number to what you calculated. Is it close or far away? Take a look, describe both of those numbers, write them down, and tell me if that's close or far away. The goal is in a perfect world that they would be pretty close to each other. So mention those 2 numbers and talk about if it's close or not. Don't forget, feel free to pause this video, answer that question, and then we can move on to the next one. Now, question number 2 is talking about when you were close. In a perfect world, what we got for the molar mass from the previous question should be identical to the one on the periodic table, but it's probably not. What is potentially the reason for that? Think about the error. So when you were doing the lab, is there anything that could have gone wrong that ends up affecting our actual outcome? So when you're measuring, are there any issues with that? When you're reacting the compound, is there any potential issues with that? What tiny little issues could have been involved with our lab that ends up getting our numbers off slightly so it's not identical to what's on the periodic table? Go ahead and pause this video, answer that question, and then we'll move on to number 3. So for number 3 here, we want to know what is a mole and how does it relate to molar mass? Take a look back in your notes. We know a mole represents a number. Think about that. But also, how does that relate to molar mass? Think about why a mole exists and what it does for our periodic table. Remember, we talked about AMUs and grams. Think about all that and write a reasonable and rational explanation for this answer. Make sure you reread it as well. Don't forget to pause, and then you can go on to question number 4. Question number 4, well, we kind of answered already together, depending on which version of the lab you have. But let's get that balanced equation again. So we had silver oxide, and we know it's going to break down into pure silver and oxygen. So once we have that, we just need to balance out the oxygens, which means a 4 there and a 1 there. We've got that balance for that decomposition reaction. All right, so now that we have that balance, we're good to go. Depending on which version of the lab you have, you may have already answered that question. Let's now move on to question number 5 and beyond. These are just going to be mole problems. So for each question, take a look at it, see what's given. Like for number 5, how many moles of calcium metal are found in 120 grams? So I already know that I'm given, there's 120 grams of calcium, and I want to convert that to how many moles of calcium that is. So I'm going to use my mole map to figure that out and then put my answer down there. Please do that for the remaining questions, and that way you'll be able to finish up your lab. So what we've done is we've done a lab where we've done a decomposition chemical reaction. We've then measured it and also did some mole map type problems to convert to moles and see if we could come up with the molar mass of silver compared to the periodic table. This is just helping us better our skills with the mole map, also better understanding what the mole is and how that relates to AMUs and grams on the periodic table as well. So keep crushing at these, work together. Feel free, if you got some lab partners, double check your answers with each other, but make sure you're doing the work yourself. In the end, you got to struggle through these, catch your mistakes to help yourself get better at them. Otherwise, great job, be well, Chem fan, and let me know if you have any questions.